From its headwaters at Lake Itasca, Minnesota, to its mouth in the Gulf of Mexico, the mighty Mississippi cuts a more than 2,300-mile course through the heartland of America, draining a 1.25 million square mile watershed that touches 31 states and 2 Canadian provinces, stretching from the state of New York to Montana. Through this vast system passes 41% of all the water in the United States. The Mississippi River watershed is divided into 6 distinct basins: the Upper Mississippi River Basin, the Missouri River Basin, the Ohio River Basin, the Arkansas White River Basin, the Red River Basin, and the Lower Mississippi River Basin, also known as the Mississippi River Alluvial Valley. On average, approximately 90% of the flow in the lower Mississippi has entered by the time the river reaches its confluence with the Ohio. The upper Mississippi above St. Louis contributes 19%. Another 11% is added by the Missouri River. Next, the Ohio River contributes another 50%. And finally, 10% flows into the Ohio from Kentucky and Barkley Lakes, just 32 miles upstream of Ohio's confluence with the Mississippi. Flowing 954 miles from Cairo, Illinois to the Gulf of Mexico, the lower Mississippi River serves as the spout of this vast system. 2 centuries ago, the alluvial valley was mostly swampland, subject to constant flooding. The river was mostly unnavigable except by small flatboats or canoes. Today, the alluvial valley is home to 4.5 million people, more than 22.5 million acres of prime farmland, more than 4,000 miles of highway, and 2,300 miles of rail, 500 manufacturing facilities, 100 power plants, dozens of ports, and one of the busiest commercial waterways in the world. All of this is made possible thanks to the flood protection provided by the Mississippi River and Tributaries Project, also known as the MR&T. The backbone of the system is 3,787 total miles of levee. Of this, 2,200 miles extend along the main stem Mississippi River. The system also includes various other features, such as floodways, headwater reservoirs, backwater areas, pumping plants, the old river control structure, dredging, and channel improvements. The Corps of Engineers' efforts to improve the Mississippi began in 1824, when Congress authorized the removal of snags that obstructed navigation. However, flood control remained a local responsibility up until 1879, when Congress created the Mississippi River Commission. Over the next 5 decades, the commission oversaw the closing of gaps and extension of the levee system upstream. By 1926, the commission declared that the levee system is now in condition to prevent the destructive effects of floods. Then disaster struck. The 1927 flood overwhelmed the levee system, flooding more than 26,000 square miles, killing 500 people, and driving more than 700,000 people from their homes. Future President Herbert Hoover called the 1927 flood the greatest peacetime calamity in the history of the country. In the aftermath of the flood, Congress resolved that the people of the lower Mississippi Valley should never have to endure such suffering ever again. In 1928, Congress fulfilled this promise by authorizing the Mississippi River and Tributaries Project. The plan represented the vision of the Chief of Engineers, Major General Edgar Jadwin. Levees would remain the backbone of the system, but would be raised and strengthened to protect against the project design flood, defined as the greatest flood with a reasonable chance of occurring. Floodways at strategic locations would reduce flood stages and take pressure off the levee system. Lastly, channel improvements and dredging would be used to better align the channel, increasing the efficiency and carrying capacity of the river. In the decades that followed, Congress modified the MR&T project to expand protection into the tributary basins. This expansion included 4 reservoirs in the Yazoo Basin: Lakes Grenada, Enid, Sardis, Arcabutla, and one in the St. Francis Basin, Lake Wapapello, to reduce flooding from interior runoff. Interior drainage improvements to hasten water away from farmlands, homes, and businesses and into sump areas where excess waters could be safely pumped out of harm's way, and protected backwater areas that provide flood storage and reduce stages during large floods, but provide protection during smaller floods. During the 1930s, Major General Harley Ferguson oversaw the execution of an experimental cutoff and channel rectification program that included 16 cutoffs that shortened the river by 170 miles. A system of bank protection using articulated concrete mattresses locked in the gains of the cutoff program and prevented erosion and meandering that would undermine the levee system. In 1955, the Mississippi River Commission undertook a comprehensive review of the MR&T, including a review of the project flood. The Weather Bureau, using the most advanced scientific and meteorological knowledge at the time, developed the Project Design Storm Series. Various combinations of historical storms and resultant floods, referred to as hypo-floods, were analyzed. The study revealed that Hypo-Flood 58A, which combined the floods of January 1937, February 1938, and January 1950, had the most probable chance of producing the greatest discharge on the lower Mississippi River. Next, the Mississippi River Commission converted Hypo-Flood 58A into the Project Design Flood by routing it through the MR&T system and producing a flow line to be used in determining MR&T levee and structure elevations. This new project flood's estimated peak discharge of 3 million cubic feet per second would be approximately 20 to 25% greater than the peak discharges of the 1927 flood. In 1973, a massive flood struck the lower valley. The flood provided critical data on the performance of the MR&T system and the existing flow line. Using data from the flood, engineers revised the existing flow line, which would serve as the basis for determining updated levee design elevations. The first line of attack against floods is the MR&T main stem levee system, which stretches more than 2,200 miles from Cape Girardeau to the Gulf of Mexico. These levees form the backbone of the MR&T system and are designed to confine and convey a project flood design of up to 3 million cubic feet per second safely to the Gulf. Although not part of the MR&T project, Kentucky and Barkley Lakes have a significant impact on the operation of the Birds Point, New Madrid floodway. Releases from these reservoirs enter the Ohio River just over 30 miles or a 1.5-day journey from the confluence area. Typically, releases from these 2 Ohio River Basin reservoirs account for 10% of the total flow of the lower Mississippi. During large floods, the reservoirs provide critical storage that lowers flood stages on the Mississippi River and reduces the frequency of operating the floodway. As floodwaters from the Mississippi and Ohio converge, they approach the next line of defense, the Birds Point, New Madrid floodway. Just downstream of the confluence of the Mississippi and Ohio rivers, the 133,000-acre floodway is bounded on the west by a 36-mile-long setback levee, and on the east side by a 56-mile-long frontline levee, which includes a fuse plug section, an inflow crevasse at the head of the floodway that can divert up to 550,000 cubic feet per second in lower flood stages up to 5 feet. Operation of the floodway occurs when the stage at Cairo reaches 60 feet and is forecasted to rise above 61 feet. By reducing pressure on the levee system, the floodway provides protection to more than 2.5 million acres. Since 1928, the Corps of Engineers has only operated the floodway twice, first in 1937 and again in 2011. The next project features are the 4 backwater areas. These areas are protected from backwater flooding during smaller flood events, but provide storage during larger floods. In total, more than 1.6 million acres are protected in the backwater areas. During events approaching project design flood conditions, fuse plug sections of levee are designed to overtop to slightly reduce peak flood stages, thereby reducing pressure on the levee system. During high water events, floodgates are closed to prevent Mississippi River flows from backing into the backwater areas. Unable to escape, interior drainage is impounded in the lower end of the backwater areas. With the exception of the Yazoo backwater area, pumps evacuate these floodwaters and reduce flooding in backwater areas. The first of these areas is the St. Francis backwater. Authorized by Congress in 1950, the area includes 47 miles of backwater levee protecting 500,000 acres in northeast Arkansas. Completed in 1977, the 12,000 cubic feet per second capacity W.G. Huxtable pumping plant removes interior drainage impounded in the lower end of the backwater area. Slightly downriver is the White River backwater area. Authorized by Congress in 1936, the area includes 40 miles of backwater levee protecting 145,000 acres in southeast Arkansas. Built in 1964, the 1,500 cubic feet per second Graham Burke pumping station evacuates impounded interior runoff. 150 miles downriver, just north of Vicksburg, we arrive at the Yazoo backwater. Authorized by Congress in 1941, it is the largest of the backwater areas. 634,000 acres are protected by 53 miles of levee, with 30.5 miles of fuse plug levee designed to overtop during extreme floods. The area includes gravity drainage outlets at Steel Bayou and Little Sunflower, and floodgates at these outlets to prevent Mississippi floodwaters from backing into the area. Although Congress authorized a pumping plant in 1941 to remove impounded interior runoff from the Yazoo backwater, the area remains only one of 4 backwater areas without a pump. We now arrive at the last of the 4 backwater areas. Authorized by Congress in 1941, Red River backwater is protected by 93 miles of levee, including 36.8 miles of fuse plug levee designed to overtop during extreme floods. During normal conditions, interior drainage passes through the Bayou Cocodrie floodgate. During high water, the floodgates are closed and interior runoff is removed by a 4,000 cubic feet per second pump. In total, the Red River backwater provides flood protection to 373,000 acres in northeast Louisiana. Just below the Red River backwater is the Old River Control Complex. For thousands of years, the Mississippi has meandered through the alluvial valley, shifting its course to the Gulf numerous times. The last shift occurred approximately 1,000 years ago when the Mississippi adopted its current path to the Gulf. By the 1940s, it became apparent that the Mississippi could shift its course once again, this time down the Atchafalaya River via Old River. In 1950, the Mississippi Valley Division began an extensive study of the problem and recommended a control structure at Old River to prevent the Mississippi from changing its course and to maintain the same 70-30 flow and sediment distribution that existed between the rivers in 1950. Congress authorized the control structure in 1954, and construction was completed in 1963. The Old River Control Complex is designed to divert up to 620,000 cubic feet per second and consists of an overbank structure, low seal structure, auxiliary structure, and the Sidney A. Murray hydropower plant. Another 30 miles downriver, we arrive at the next line of defense, the Merganza floodway. Completed in 1954, Merganza floodway includes a 3,900-foot-long, 125-bay gated intake structure that can divert up to 600,000 cubic feet per second from the Mississippi River through the Atchafalaya Basin, and then down to the Gulf. Combined with diversions from the Old River Control Complex and the Red River, Merganza floodway can pass half of the 3 million cubic feet per second project-designed flood through the Atchafalaya Basin. The floodway has only been operated twice, once in 1973 and during the Great Flood of 2011. Operation of the floodway occurs when discharges below the floodway are forecasted to exceed 1.5 million cubic feet per second. As the project flood makes its way downriver, discharges would continue to increase and more excess flow would be diverted through Merganza until flow reaches 600,000 cubic feet per second. Diverting this excess flow lowers flood stages and reduces pressure on the MR&T levee system downstream. The remaining 1.5 million cubic feet per second flow would continue its journey another 150 miles downriver before reaching the MR&T's final line of defense, the Bonnie Carey Spillway. Completed in 1932, the floodway is designed to prevent Mississippi flows from exceeding 1.25 million cubic feet per second. To accomplish this, the floodway can divert up to 250,000 cubic feet per second from the Mississippi River into Lake Pontchartrain. Operation occurs when discharges below the spillway are forecasted to exceed 1.25 million cubic feet per second. Timber needles are removed by cranes to allow floodwaters to be diverted through the floodgates and into Lake Pontchartrain, lowering flood stages and reducing pressure on the levee system downstream to protect the city of New Orleans. The spillway is by far the most frequently used, having been operated 15 times in its history, most recently in 2020 and twice in 2019. Since Congress authorized the project in 1928, the MR&T has been tested numerous times. Large floods in 1937, 1973, 2011, and 2019 challenged the system, but the MR&T stood firm. Of these floods, the historic Mississippi River flood of 2011 was the greatest, producing flows up and down the valley not seen since the Great Flood of 1927. But unlike the 1927 flood, the MR&T passed record flows without a single levee crevassing. When the floodwaters finally receded, the MR&T had prevented flooding on 16 million acres and 110 billion in economic damages. In this single event, the MR&T had justified the investments of Congress and the great people of this nation several times over. Time and time again, the MR&T has proven itself to be one of the most successful civil works projects in our nation's history. The success of the MR&T is the result of 2 centuries of hard work, inspiration combined with perspiration, and has transformed the alluvial valley into the alluvial empire.